In this video, I want you to give a brief recap of everything we have learned in reinforcement learning so far. So, before we move into the policy gradient algorithms, I want to make sure that the mental models of each of these concepts is clear in your mind so that we do not get into the concepts and algorithms of policy gradient with the wrong mental model. So we started with understanding that why do we need reinforcement learning for LLM reasoning, and we saw the problem with supervised fine tuning and why supervised fine tuning might not be the best method for inducing reasoning into LLMs. And then we understood the basic elements of a reinforcement learning problem, and we saw that in a reinforcement learning, we have an agent, we follow a policy pi, and we transition from a given state to another state. And we saw that we take an action to move from a given state to another state. And we saw that a complete one trajectory represents moving of an agent from the initial state to any terminal state, and we saw that for any action that we take in the environment we get a reward for it. So once we understand the basic elements of a reinforcement learning problem, we can now work towards the solution of that problem. So in order to solve reinforcement learning problems, I introduced you to the concept of value functions. We saw that the value functions help us estimate the value of the two of the most important elements in a reinforcement learning problem, which is the value of a state and the value of an action which is taken in a certain state. And I told you that whenever we talk about the state value function or action value function, it is always according to a policy pi. Whenever we are estimating the value of a state, it is always according to a policy pi. Same goes for an action. When we are estimating the value of an action for a given state, it is always in accordance to a policy pi. So you see that whatever you do, you always encounter the same elements you that we have discussed before. You are always encountering an agent, an action, or a state. You get a correct according to a policy and you get a reward, etc. Everything is the same. You always encounter the same elements. Then we also saw that what is the concept of return, and we came to know that a return represents a return at timestamp t represents all the future rewards that you can get from this timestamp t. And we saw and we understood the concept of discounting, that future rewards might not be because of something I did at timestamp t, and in order to minimize the effects of the future rewards, whether they were good or bad, we discount them using this factor called gamma, the discount factor. So by now we have sort of the meat of reinforcement learning. We can solve any reinforcement learning by having this information. Now these everything that we have learned so far is stands can be understood in a standalone fashion, that you understood that in order to estimate the value of a state, I'm going to use the state value function. In order to estimate the value of an action, I'm going to use the action value function. If I need to calculate the return at any given timestamp t, I can use this formula. And then we saw the concept of the Bellman equation, that if I want to calculate the value of a state, I can use the Bellman equation. And then if I need to update the value of the state, I can make help of the Bellman equation and use two algorithms. One is the Monte Carlo method and other is the temporal difference method. In order to update the value of a state or update the value of an action, I can use the Monte Carlo algorithm or I can use the temporal difference algorithm. The difference between the two is that the Monte Carlo method estimates the value of a state from the actual return we get in that trajectory, whereas for temporal difference, in order to estimate the value of a state, we use only the next state, the return or the value that we get in the very next state. Then after it, I introduce you to the concept of the advantage function, that what is meant by the advantage of taking action A in a given state S. And we came to know that if the advantage of a function is positive, it means that this taking this action for this given state S is going to yield better returns than the average return we are getting so far. And if the advantage is negative, it means that taking this action A in the state S is not better than what we already get for the state V. So this V of S represents the average value or the value that we normally get whenever we are in the state S. So what, in order to calculate advantage, what we do is that we subtract the action value of a given action from the state value of that particular state, so we can estimate that how good is this action from what we normally expect from a state.